Hello class, this is lecture 14 for Econ 4001.02, and I'm your professor, John Raybeck. Great, so this lecture will just cover solving the utility maximization problem with Leontief utility. So, sorry about this. I'll correct this in the slides, not linear, but Leontief. So now we're going to do Leontief utility maximization. And we're going to consider this problem when we have two coefficients, a1 and a2. And now we have that, the utility function is given by this Leontief one, where recall indifference curves are given by these L shapes. And again, that we're going to have that this is monotonically increasing. So if I increase x1 and x2, remember, this is going to increase, both of these, so that we're actually going to be on the budget constraint when we do this. This case, it's also harder to use the Lagrangian than just, kind of following your nose. So we'll show how to do this with a graphical method, and then we'll show how to kind of turn it into a cookbook recipe in order to solve. Great. So again, we'll put good 1 on the horizontal axis and good 2 on the vertical axis. And here we've got good 1 and good 2. Again, we'll put the budget here in orange. Here, the axis and slope won't end up being that important, but as good practice, we'll put them in anyway. So m over p1 and m over p2. And the slope here is equal to negative p1 over p2. Again, we can graph, kind of the indifference curves, right? So recall this will happen when u bar equals min a1 x1 and a2 x2. And here, this is going to occur, the way we're going to do this is look at the corner. So we have u bar equals a1 x1 equals a2 times x2. Right, so this is going to be how we find the corner of the indifference curve. So here we'll have u bar 1 less than u bar 2 and u bar 3. So if we do this, we'll have something like u bar over a2, 1, u bar 1 over a1, there. We got this here. And we can graph our indifference curve. We can have higher and higher ones as well. So if we do this, I can find maybe U2 occurs here. And here, there's not going to be any way to do better. And maybe U3 is over around here. Right, so each one of these will intersect at, the following points, right? So this is U bar 2 over A2. And this is U bar 1 over A2. Sorry, U bar 2 over A2. Oh, and this is supposed to be A1. Sorry, my bad. A1. So we have this. So this will be the optimal thing. And basically, what we find here is this is corner plus budget constraints. Right, so we're going to just use this corner condition and the budget constraints in order to find the optimal point. Right, so now again, we're just going to look for a cookbook method to operationalize this. We can do the algebra. So the main method is just use coordinates and solve the budget constraint. So the idea is anything not on the corner, so anything where A1 times X1 equals A2 X2, or sorry, not equal to the corner, right? So this is the corner. If it's not equal to the corner, then this happens. Then this is going to increase the cost I spend without increasing the utility, right? I need to increase it at the same rate of X1 and X2 being on the corners in order to increase my utility, or your utility. Finally, after we get these corner conditions, we just plug the results of this into the budget constraints. So again, if we do this just for the general case, we get the corner condition is given by A1 X1 equals A2 X2. So this implies that, X2 is equal to A1 over A2 times X1. And finally, we can use this in the budget constraint. So for budget constraints, I'll sometimes just write BC because it's going to be a little bit easier. So here we have P1 X1 plus P2 times X2 equals income M. And we plug in X2 here. And if we do that, we get P1 X1 plus P2 A1 over A2 times X1 is equal to M. And a nice way to do things here is we like to keep the coefficients of, each good together. So, here we'll separate this out into X1 times P1 over A1. And this happens by dividing both sides by A1 plus P2 over A2 equals M over A2. Right, but then in fact, we get that X1 star, again, as a function of P and M is just equal to M over A2 over P1 over A1 plus P2 over A2. And we can also do this for x2 star, right? And if we do this, we can just plug it in and simplify things. Oh, sorry, this is supposed to be an A1 here. And then A1 there. Right, so if we plug it in, we have M over A2 over P1 over A1 plus P2 over A2. So this is our general demand functions and the general algebra, right? So if you just have A1, P1, P2, you can always check your answer by using this. But if you're solving something on a quiz or something and it asks you to show the steps, make sure that you show your steps in solving the Leontief utility maximization problem. Great. And that does it for Leontief. So this lecture discussed how to solve the utility maximization with Leontief utility functions. Again, it's mainly just a cookbook method, right? So we're not doing anything systematic yet, but we're just kind of following our nose after drawing some indifference curves. Great, thanks for listening, and see you again soon.